Hello, can you hear me? Yeah. Hi, konnichiwa. I'm Thibaut from France. I'm going to share a little bit of perspective on my work using Ruby for data processing tasks, and in particular ETL, which I will define with easy to understand diagrams. So it won't be super technical, but I want to give you patterns and a perspective on how time flies, the past, present, and the future. And before that, I want to thank Mats and the Ruby committers. So arigato gozaimasu, because they make my life nicer as a programmer. I've been using Ruby since 2005, and I'm very happy with it. So Kiba ETL, what is it? It's a lightweight generic data processing framework for Ruby. So I'm going to explain first what led to its creation, how I'm using it on a daily basis, and I want the outcome for you to be to understand what the solutions are, which solutions are available in Ruby, how you can use them, and to trust the future. Okay? So first, why Kiba? Kiba in Japanese means fang, unless I'm completely mistaken. So it comes from, this is my parents' dogs. And the idea is that with your fang, with the Kiba, you can bite into the data. So you can control it, and you can manage it, and you can modify it, okay? Then what is ETL? I really want to underline this word, because this is something like Mats explained this morning, that if you know the concept, you can Google for it, and you can find solutions for it, and you can find books on it, articles, and everything. So keep that word in mind. It means extract, transform, and load. It's really like you take some data from one place, you extract it, okay? And then you have a kind of pipeline, and you transform the data you have extracted. And then you have the load part, which will pour the data into a destination. So it's a very, very commonly used word, but not very famous in Ruby. And I encourage you to check out my blog, where I detail more about this concept, how it can help you as a Rubyist, as a coder, and what type of books you can find on it, okay? You will have more content on my blog again. So if you need to really provide some kind of picture to describe it, it's like a kind of pipe, really, okay? Imagine you have water coming from the source at the top, and then the data flows through the transforms that you are writing with Ruby. You can transform data as you go and malax it, and modify it in a way that fits your needs. And then you go to the destination, which in some paradigms is called a sink. So you can find this type of visual definition in a lot of data processing tools today, okay? Back in time, I'm going to take you a bit back in time to understand why Kiba was created in the first place, because it builds up on prior work, okay? I started in 2006. I found a gem called Active Hours ETL by a guy called Anthony Eden, now founder at DNS Simple. And I really felt in love with the tool. I had been using GUI tools, you know, click and point stuff to describe the data processing I needed to achieve. And it was really a headache. You couldn't version things. You couldn't put things under Git. You couldn't easily use your daily editor. So it was really a mess, okay? So this gem allowed you to reuse a very nice, can you see it? Yeah, okay. A very nice DSL declaration. And it's the first DSL which I really found useful on the very long run. You can declare, actually, the processing. It's not an imperative model, it's a declarative model. So you declare the source. Which type of source? Here it's a file source. You are going to grab back data from a CSV file, and you can configure it. And after that, you can achieve some transforms and a destination, which is, again, a file type of destination, but you could also have the databases. So it looks nice on paper, but actually, on the very long run, it helps with maintenance a lot, because you can easily add something, remove something, unlike with method chaining, for instance. For the record, some of the ETL I wrote in 2006 were still in production last year, almost unmodified, so more than 12 years, okay, in Ruby 1.8.5. old stuff, okay? So you could define transform using blocks. You had a way to filter out rows and everything. So yeah, and you could go a bit further in terms of abstraction. You could write Ruby methods to call operation that you would put under test elsewhere, or reuse some components to some extent. But mostly it was using built-in components. It was kind of hard to customize. Okay. And after that, you had Ruby command line that you would run, and it will interpret the declarative structure that you've seen, and then it will run it. So read the sources, push the data to each transform, and then to the destination. And here, it really helped me escape the hell of GUI tools like Microsoft tools with a point and click everywhere, where you cannot really know what's happening actually, even if they are really convenient otherwise. And I was able to deploy ETL with Capistrano tools, so it was a great solution. Thanks to this gem, I was able to create many different data extraction, that's what you call data pipelines today, okay? During 6 years. So I would extract data from a CSV from a costly CRM to import into MySQL and make some basic business intelligence solution. You could move some data to a Rails app where after you geocode some records, and you could do all types of things. I was even able to build a connector to send data to a COBOL mainframe backend. Okay. And you can find more detail on YouTube. There's a link at the bottom I will publish the slide. At some point I took over maintenance because Anthony, the original author, was going to work on something else. And even if I only used a tiny part of the features, I really felt it was so sad to lose such a solution, because it was a great fit for Ruby. We have a really nice DSL, and a DSL that really brings value on the very long run at writing time, but also at maintenance time. And we know that maintenance is what really costs. Okay. So I also wanted to ensure availability for my consulting clients and for my own needs. So yeah. But I quickly realized that there were lots of stuff in that library. It did a very large feature set. The features were a bit complicated to use at some times, making assumptions. So it was both making too much and too little at the same time. For instance, this is a copy-paste of the CSV source. Okay, so it's maybe 300 lines with very specific handling and everything. And I'll show you the Kiba version later. So at some point, as a maintainer, because I have 2 kids, I'm a remote freelancer, so I need to handle my business. And this was done mostly as extra time and weekend time and everything. So this is my continuous integration server. At some point, it was like always in red, always burning. And I felt like maybe I worked 2 months in a row to try to just fix the CI build. And I could never make it. So sadly, I was very sad that day, but I decided to stop the maintenance and to take a step back. The reason were too many features, but at the same time not composable together, features lacking flexibility, so you needed something slightly different. It wouldn't work. It was tightly coupled to Active Record, and it was costly to maintain for me as a solo developer. I was very sad, but I still had those data processing needs and some clients with needs. But I was happy about the true gift about ActiveOS, which was the syntax, the use of the DSL. Really felt clever, and I really didn't want to lose that. The core ID was great, but there was too much bloat, like the guy from Robocop said on the other talk. So I thought it would be a shame to lose that. Then I remember that a few years before, I actually had written from scratch re-implementation of that same gem, but as a very tiny, very minuscule implementation, only a few hundred lines, 100 and something. And I used that to write small data pipelines into production apps. So I remember that, and in 2015, I took a bit of time, but not too long, it was maybe 30 hours total, to take all that I learned and put it into an easy-to-use gem, which would be easy to maintain for me and easy to use for you. I wanted something to be, the exercise to be sustainable, no risk of burnout, like friends in the open source world, and I thought less is more, etc. Okay, so now I'm going to show you the core parts of Kiba, so you can have a good understanding. Only 5 keywords. Pre-process and post-process are blocks that are executed at the very beginning or at the end. At the beginning, if you need to, for instance, download something as a bulk before you process it. Post-process is the same. Maybe you want to run a quick report without launching a second script. And then you have source, transform, and destination. That's it. Kiba core does not provide you with components. It just provides you with a convention that you must follow. And if you follow it, it's easy to implement components. So I provide the guidelines, the grammar, but not the components, which were costly to implement right and to be flexible. So here is an example of declaration of actual data pipeline. So first you have the source keyword, and then you place the name of the class, which will be your source. Here it's a CSV source, and some components for a configuration as a hash. Same for transform, and then the destination. In the case of the source, if you need to implement a source, it's easy. You implement the constructor, the initializer, and you must take arguments, and then you do the work required to prepare your source. Then the only other method you need to implement is each, and your role as a component implementer is to yield the rows of the source one at a time. And you could actually stream indefinitely or on a small batch of rows. This is an example to be compared with what we see, with what I saw earlier in terms of complexity. This is a simple CSV source. I just pass the file name and the CSV options, and then I iterate on the file, and I just yield the rows one at a time. Okay? So this is plain Ruby object, plain old Ruby objects. Much easier to test, no dependencies, no complicated stuff, and the interface that you must follow is very simple. For transform, which are responsible for modifying the data, you can use a class definition with a constructor and then a process method responsible to either return 1 row or 0 row if you want to filter out the row from the pipeline. You can also conveniently use a block if you need something very quick. Okay. In Kiba 2, I'll show you later, you can actually yield more than 1 row per each input row. One input row could generate 10, 5, or a larger number of destination row. And similarly, the destination, you have the constructor, a write method, where you get 1 row and you do the job, and a close method, so you can maybe close the resources. Here is an example of destination, so as well, it's quite short and sweet and easy to maintain and test. It's a plain old Ruby object again. So for the last 3 years, I've been using this on numerous production use, and maintenance for me as an OSS developer is easy. Almost no core change to Kiba itself. The components were easy to author and maintain for me and my clients. So the long-term support and the sustainable approach is doable for me as a solo developer and a family father. So yeah, the outcome for you is that you have a solution for data processing that you can rely on without too much fear that it will be left abandoned at some point, because it's easier for me to keep it alive. Okay, now a little bit on sustainable project evolution, because we see a lot of burnout. Because of the very tiny aspect of Kiba itself, I've been able to improve the Kiba core with a version 2, extract a Kiba command version which is also open source with a number of helpful components, and also start working on the Kiba Pro version, which provides specially designed tools for fast SQL or Amazon S3 Exchange, data profiling, performance profiling. But again, this is on a subscription model, but in a sustainable fashion for me, without the risk of burnout that I mentioned before. Now I'm going to go through 4 patterns that I see and work on regularly that you will know you can trust. The outcome for you is that you can detect these patterns and say, okay, Kiba is maybe a good fit for that. So first is micro batches. When you have, say, less than 50,000 rows per job, and you want to achieve very near real-time synchronization. Here is a diagram because it's easier to see. Imagine you have a company with a very big CRM, so internal software, and all the operators are using it to modify some configuration or some data. Then you can implement some lightweight data streaming, data synchronization to extend the app with outside Ruby applications. So, because usually the CRM are very expensive, and if you want to buy one module, sometimes with a mapping, for instance, you are going to pay very big bucks. So it's quite convenient to be able to extract that data to your own Ruby apps that are done on purpose. It's a kind of microservice approach in a way, because you are passing batches of data to synchronize everything. So you can actually drive Rails application. I mean, the configuration of the Rails application can be data-driven from the internal software. So this means that non-technical people can change setting, and you will update the configuration, and then your Rails app or your Ruby app will will adapt its behavior thanks to that thing. You have different modes to handle that. The first mode is a push mode, where you have one little script on the nearby the CRM, so the internal tool, and you adapt, you extract, and you process a bit of the data to create something like a file, which you can post via HTTP to a Ruby app, can be Rails or Hanami or whatever, and then you use Sidekick and Kiba to grab the data back and process it and do whatever you need with it. A more sophisticated way to do that, if the CRM is able to tell you, okay, some data has changed, just that signal, then it has an API, then you can only use the signal to know that you have to fetch and use the API to fetch back some data, because it tells, okay, some data synchronization is needed, but you can do it now because records have changed. My recommendation for that case is do not shell out from HTTP or Sidekick processes, because the process that you are creating, like in Active Warehouse, you were required to use a command line approach for that. If you do that, you will have lost processes lying around. And if you have too many requests and creating shells everywhere, then your machine will just, die. And you won't have a high quality of service. Instead, Kiba now provides a programmatic API, which means that, for instance, from a Sidekick job, you can directly parse the source, transform destination, and then run. And you can wrap everything in a SQL transaction or whatever you need. If you go a bit further, so obviously this costs much less than shelling out to a process, because you stay inside the same Ruby interpreter. And on the long run, you want to extract the definition to proper classes, which you call from Sidekick or from HTTP, so you can have a nicely structured design, and you can have a test. You really want to have tests when you do data, and you want to be defensive. It allows to keep things dry as you add more features. Okay. The second typical pattern is more complicated, is a multi-step batch processing. I call that enterprise data aggregation. Imagine you have many client systems which are all different, and they all provide different formats and different extraction methods, different input files, different fields and data can be different. And you want to grab this back in a single database because you want to provide something out of that. If I make a picture, it looks like this. So you have all the various ERP or CRM or whatever. And you want a daily data export or an hourly data export, and you want to put that into your nice Ruby SaaS product. To achieve that, you need to think about the pipeline. One thing that I found really easy to follow is when each step, a step is really a Kiba script. Each step provides files to the other on the disk. So you have the ERP, maybe you get an email with an attachment, with a zip file. Once it's extracted, you pass it to a transformer script, which does all types of verification. Are the dates correct? Are the fields provided what I expect? Should I raise an error? Should I fail fast to make sure that we don't integrate things that we don't really understand? You have to be very, very defensive. And then in that case, you conform the data, you put it in a single format, which is in a separate step again, and then you move it to the target database. So again, using files as message passing between the steps is easy to do and works really well. You have to keep things simple, so in that case, you don't need this to work from Sidekick or HTTP. Maybe you just need a cron and a bash, and you can just do a sequence. You call a sequence where you execute each ETL script one after another. And you notice that you have some common scripts, common steps, and you have some client-specific steps. So as you go, Ruby allows you to say, okay, this looks similar, or maybe this is the same HR system providing data, but slightly different. Maybe I should try this, like we do in programming. So you really can apply the recipe for programming to the ETL and data processing. And this is very valuable to Ruby programmers. A single bash script can go really a long way, and each step provides files for the other one. Once you add more, you can actually have very, very complicated pipelines. Like I only put 5 sources here, but actually I'm at 10 currently on this specific project. And each has its own cron job and bash, and there is some form of reuse between the various pipelines, but not too much. So it's easy to maintain. You can reuse steps between clients. Another thing I learned while doing this is that Amazon S3 can act as a very nice inbox for you if you can use Amazon. For instance, imagine you have one email from a ERP. It's a specific format. Then you can configure Amazon SES to create a mailbox that will directly, when it receives something, put it as a file in S3. Okay? Same, maybe you have a ERP which provides some SFTP upload, so you just provide a SFTP server and then it will relay to S3. Or for more adventurous of you can provide Capybara and a headless browser to go through the site, provide the credentials and download the XLSX file, which you then put to S3. It's a great thing to use because you can think of it as a scalable inbox, because the process that will process it afterward doesn't have to be the same nor on the same machine. And it also standardized the input method, which is really great to avoid getting a big mess when you have more than 10 or something pipelines. So this is just an example of step reuse. If I want to pre-extract from S3 to a local system, maybe I move things from, they get delivered into a /unprocessed subpart of the S3 bucket. And when the extractor has downloaded it locally, it will move to processed. And then you put Amazon lifecycle rule to delete the files after that, so you don't keep data lying around too long. So keep in mind that Amazon S3 is great. You can use it even as a message passing between machines. You could use it as message passing between the steps, which means that Ruby scales with the cloud very nicely in that case. You receive from one part, there is one process on one machine, and then the transform is done by another machine, maybe more RAM and CPU heavy, maybe only started at one specific time because it's very costly, and then you shut it down and you can move to another, like really an inbox. I'm just giving you a letter and you can do the work. So you can have many different machines with micro batches or batches. And also, you can keep things dry and enforce reuse, like source transform declaration, the components, but also meta transforms or whole steps, like we saw, like the thing that we'll download from S3. Because the main cost is maintenance. So you want to make the effort to keep things dry and to extract what can be reused. So when you come back to it, it's easier to manage. Here is an example of actual component reuse between pipeline. I need to have some transform that will put a default value to a field if it's not available, if nothing in there. So you can use it you can declare it in a separate file, and then you can reuse it easily. And it's easy to unit test as well. And over the long time, I can tell you that you have more and more and more and more reusable components, but which are specific to your project and not bloated with the needs of the neighbor on an open source project. So these are all examples to provide the default value, to verify that a field has a value which is part of a certain range of allowed value, etc. The third one is automation of internal tasks. So I'll go a bit quickly on that because it's a bit similar. You have banks, you get data from it in different formats. Maybe you have an invoicing system and you want to reconcile the whole thing. So this is also a good fit. And you can build a system where a part of the processing is done by human. So maybe you want to ventilate and to categorize transaction in an automated fashion, but then after you still have a human open LibreOffice to verify, or use some kind of GUI to verify what's happening, and maybe git commit so that the learning chain can improve. So you can put human in the loops, and as a result you can increase productivity and have a reproducible process for things like boring things like VAT declaration, so you can save some time and avoid mistake. Okay, so I go quickly on that. You have a HTTP fetcher from a bank, and then you can verify the currency, is the type of the value correct. You can and then you pour it into a database. It's quite easy to come back to such a script 2 or 3 years later, as I mentioned. Okay, this is another one with OFX bank sources. You can even extract data from PDF files. In that case, I need the number, which is in red, which is the USD Euro exchange rate, which is provided on the French government site. So I grab it, and I can write something that will download it in a preprocess and will extract it. Here you can shell out to a command from outside, like PDF to text, to actually say, okay, transform this to text, and then I use some checks to verify that the data is what I think it is. Finally, the last use case is big rewrites and data migration. So you have a PHP MySQL setup, and you really want to move to Rails with Postgres, with completely different tables and different concepts. My recommendation for that is that you start the development of the new app, but at the same time, you write the ETL side, and you iterate on the ETL, you add screen. I'm going to show you what are screens, and then you build a CI with a subset of the original data. So you have to consider that the ETL must be developed side by side with the application. So, okay, I migrate one table, maybe I add one field, so you can be very, very agile for data migration. And as you know, big rewrites are very difficult projects, so this provides some visibility and some help really to make it successful. One concept useful concept is data screens, which are automated tests that you can apply on the data. You can use mini tests like this to test a few well-known records on the target and compare it to the source, and you can actually query it. I recommend that you use the SQL library for that, and you can make some tests on some specific records or on data as a whole. And you can do TDD, big rewrite development this way. It works. The key takeaways from data migration, which are difficult projects, is that you really want to use bulk insert. There is one in Kiba Pro, there are one in SQL, or whatever works for you, but don't insert records one at a time. Use deterministic IDs and a reset sequence, okay? Arigato. You can also, I recommend that you bypass the active record validation because they are slow as hell. So you can use this little trick unless with ETL running. So you just pour the data in the target and maybe you do a group analysis at the end to verify that something would work, or you try putting an index. You really want to bypass the race migration. And you work on the data subset to avoid being lost in the volume. Okay. Now, why Kiba v2? It's mostly drop-in replacement, but over time, because I've been writing components for quite a while now, I stumble on that case quite often. It looks good at first time. It's a class with 4 responsibilities: directory iteration, so which files are available, XML parsing, XML node search, and exploding, because each XML has many rows in it, and I don't want one big row, but n rows. I must re-implement directory iteration and other concern for each component, example, a CSV source. So it's hard to drive with Kiba v1. So I used the Ruby Enumerator class to make sure that transform would be able to provide more than one row per input row. So this is a bit technical, but I really use the enumerator, and it's a great complement to Ruby in general, because without that it would be difficult to do. So each transform can yield n rows, which means that I can write what is at the bottom, iterate, I have one thing which iterates over folders or over files, and then I can use the enumerable exploder at the bottom, which will receive the whole file as a row and explode it into n rows for each XML sub-element. So this makes it easier to have a more long-term data solution, because you can write very specific components, the Unix philosophy, and you can mix and match them together. So in short, I'm happy with the current data processing toolkit with the Kiba Command, Kiba Pro, but most importantly, with tons of gems for pretty much any format that you may dream of. I've been using Elixir, for instance, a lot, and actually I'm keeping it for high scalability needs now, and I'm back to Ruby, because there are more choices for pretty much any format that you want to use. So it's more maintainable on the long run, and it has a good dynamic. Also, as you will see in the other talks, there are more performance available soon. And for that line of work, data migration or synchronization, performance does matter. And yes, Ruby was too slow in the past. Well, kind of slow. It's really improving, and we have good options like Truffle Ruby, the keynote from that you will see in 2 days, Ruby 2.6, JIT improvements, the GIL and guides as well. You have also a good, this is my own Kiba benchmark. The left bar is Ruby 2.00 relative as a baseline, and Ruby 2.5 is on the right. You're almost 2 times faster without doing anything. So single performance matters, but here the Ruby speed and productivity boost is also comes with the improvement of speed as you go. So don't be too scared about performance issues when dealing with data. Okay, in short, data and Ruby for me is a match made in heaven. Even if it's less large than some ecosystems like Python, you have great assets for doing data integration. You can do a lot of dry code, and you have a wealth of libraries to tap into. The raw speed is really improving, and the concurrency story is also going to improve. So I'm quite happy with the setup. Okay, I'm done with the presentation. We have 5 minutes if you have specific questions. Arigato. You need to turn the mic on.
Yeah.
Yeah.
Thank you for presentation. Do you have any retriable mechanism on the several in a file or several scripts? If some job is failed, can we retry from the specific job?
Sorry, I didn't get you. Can you translate? You mean retry for jobs?
Yeah.
Okay.
Something job is failed. Yeah.
Okay, for job is failed, it's up to you to implement it in that case. My recommendation for that line of work is to be fail fast, which is very defensive programming and raise exception as soon as something is not planned by the data pipeline, because otherwise you end up with very nasty things at the destination. So I recommend that you raise an error and then you really think about what is a good way to retry, because just retrying, without thinking about it is a problem.
Yeah.
If you use, for instance, in some cases with the cron jobs, we monitor them with Chronitor or stuff like that. We get an error, and most of the time it means that we need to actually look at the data because something bad occurs. When you deal with Sidekick, you can try retries, but then you have to be careful about how you do this, because this is really business specific. So there is no generic retry mechanism.
Thank you.
Hi. Thank you for the presentation again.
Thanks.
For similar things, I've been using Logstash before, and definitely there's advantage here, for the flexibility especially, because writing a plugin for Logstash is quite complicated.
Yeah.
But one thing they provide is watchers, right? So when you write almost real time, you want to have a migration of data almost real time, you don't have to cron job things. You can just run even 4 or 5 pipelines, and they will write to folders the same way you do, but more in real time. So do you have any plan on thinking, implementing this kind of watcher and more launching your ETL as servers, running all the time and just waiting for new data to income?
Yeah, actually you can do that. I didn't have the need so far. I've been doing a bit of streaming, so it's more continuously checking. Yeah. So maybe if the input has a way to do that, but otherwise I would probably just implement with a Ruby notifier library, because they are working well. So just write a source and bind events to that, and keep the process alive with a monit or systemd to keep things going. But there isn't a fully fledged for that. Actually, it's quite a design choice, as you saw, because implementing myself would lead to the situation with ActiveWare's ETL. Because some people would be happy, but you can always implement it yourself and put it, because the implementation is quite easy to do. Okay? We can discuss that separately as well if you want.
Sure, okay. All right, thanks.
Okay. 2 minutes, one more. Okay.
Yeah, I have a question. So do you have any experience or suggestions about extract data from an unstructured or denormalized data source like MongoDB and load it into a structured database?
Yeah. First, in that case, because it happens sometimes, or you have blobs of JSON or whatever, you have to figure out what is the actual schema or the actual schemas, because maybe you have 3 different schemas. And you have to find a way to detect the cases and to conform, what they call conform the data, so transform them to something very similar. And you have to be very defensive again for that. So yeah, there is nothing built in specifically for that, but my advice is to be very defensive. Try to think about what is the hidden schema, because there is always one. And think about it and write for each case a kind of plugin, to handle that.
Thank you.
Welcome. Thanks for your attention. Arigatou gozaimasu. If you have more questions, feel free to reach out.